Sorry about that. Here's the continuation of the notes. So average velocity is the change in distance and the change in over the change in time. So a ball is dropped from a height of 100 feet. The ball's height, which we're going to use the letter S, at time t is the position function. S is equal to negative 16 t squared plus 100, where S is measured in feet and t is measured in seconds. We need to find the average velocity over the time interval 1 to 1.5. Now, no, I said interval. That is not a point. Okay. Basically, you are starting at 1 second and you are ending at 1.5 seconds. Okay. On your time. This is an interval, not a point. So right here, what we're going to do is you're basically doing the slope formula. Okay. We are doing the slope formula. This is 1 second to 1.5 seconds. So we're going to take the change in S over the change in time. Now, that is basically going to be your y2 minus your y1 over your x2 minus your x1. How do we find y2? This is going to be your x1. This is going to be your y1. I mean, x2, sorry, x2. So what we're going to do here is I first need to plug in 1.5 into the function. So that's going to be s of 1.5 minus s of 1 divided by 1.5 minus 1. If you want, go ahead and plug in 1, write out the point. Plug in x2, find out the point, and then just do your slope formula. I'm going to go ahead and plug in 1.5, so that's going to be negative 16 times 1.5 squared plus 100. And I'm going to subtract that to now I'm going to plug in the number 1, negative 16 times 1 squared plus 100. And then right here, 1.5 minus 1, that's just going to be 0.5. So let's plug all that in. Alpha y equals negative 16 times 1.5 squared plus 100, close that parenthesis, minus negative 16 times 1 squared plus 100. And in the denominator, I have 0.5, and my answer comes out to be negative 40. So the answer here is negative 40, and the units is feet per seconds. Whenever they say instantaneous velocity, that is the velocity at just one specific point. That is the velocity at one specific point. So right here, like here, I gave you an interval. On this one, it's going to be at one specific point. So this is when we use the limit as the change in time goes to 0 of S of t minus all over delta t. In other words, you're just taking the derivative at that specific point and you're done. You are just taking the derivative at that specific point and you're done. So I remember when I taught you guys the definition of a limit, I told you guys there's going to be a faster way. This is the faster way. So this is the last example here. At time t equals 0, a diver jumps from a platform, diving board, that is 32 feet above the water. Because the initial velocity of the diver is 16 feet per second, the position of the diver is S of t equals negative 16t squared plus 16t plus 32, where S is measured in feet and T is measured in seconds. When does the diver hit the water? Now, keep in mind, they give you the position. So when the diver hits the water, that means that the position has to equal 0. That means that the position has to equal 0. So go back to your position equation and just set it equal to 0. So I'm going to set 0 equal to negative 16t squared plus 16t plus 32. I notice that 16 goes into all of these, and I'm going to factor out the negative. So this is going to be negative 16. That's going to be t squared minus t minus 2. Because negative times a negative gives you the positive, and then negative times negative gives you the positive. When I factor this out, this is going to be a t minus 2, t plus 1. Now, when you do the zero product property, you don't have to plug 16, negative 16 equals 0 because there's no variable there. Right here, that means t has to equal 2 because you add 2 to both sides. And right t here, t equals negative 1. I'm going to go ahead and cross this one off because I can't have a negative time. So basically, when are they going to hit the water? At 2 seconds. The diver hits the water at 2 seconds. Now let's go ahead and let's do this instantaneous velocity. What is the diver's velocity at impact? So remember, he hits the water at 2 seconds. So basically right here, I'm just telling you to do the derivative at time 2 seconds because that's when the diver hits the water. So in this case right here, I have if S of t equals negative 16t squared plus 16t plus 32, I'm going to go ahead and just take the derivative. Bring the 2 down, that's going to be negative 32t plus 16. And then I just have to plug in the number 2. So the derivative at 2 is going to be negative 32 times 2 plus 16. So negative 32 times 2 plus 16, and my answer comes out to be negative 48. So here I get a negative 48, and the units is going to be feet per second. So what is the diver's velocity at impact? The diver's velocity at impact is negative 48 feet per second. And that concludes the notes.